Quadratic sequences. Okay, what is a quadratic sequence? Well, a quadratic sequence is when in the formula you have an n squared somewhere. Well, n squared will be the highest power. So for example, we could have, well, you can still have numbers and you can still have some n's in your formula, but the highest power will have to be some n squared. So something like this would be a quadratic sequence. So let's first of all see what numbers are generated by this general formula, this formula. So obviously the first number, what would you get? Well, if you put 1 into here, you'll get 1 plus 2 plus, well, 1 squared is 1 times 3, that's 3, isn't it? So that will be 6. If you put 2 into this, you're going to get 1 plus 2 times 2 is 4, and 2 squared is 4 times 3 is 12. So that's 17. 3, well, 1 plus 6 plus 3 squared is 9 times 3, that's 27. And that's going to be 34. I'll just do one more. So putting 4 into this equation, you get 1 plus 8 plus 4 squared is 16 times 3 is 48. So that gives us 57. So our sequence that we've generated is 6, 17, 34, and 57. Okay, now how will we know that we've got a quadratic sequence? So what we're going to do is work out the differences between the numbers. So obviously we need to work out what's the difference between 6 and 17. In other words, what do you add on to 6 to get 17? Or basically 17 take away 6, which is 11. This one will be 17. This one will be, what's that, 23. So now obviously the first differences are not the same. So we need to go to the second differences, which are going to be 6 and 6. So the rule is when the second differences are the same, this is the first and this is the second. When the second differences are the same, then it's going to be a quadratic. Okay. So we will always be able to spot that we've got a quadratic sequence if the second differences are the same. What we need to do now is to find a method. I'm going to show you a couple of methods for taking the sequence that you've got and working out what was the formula. So we kind of have to work backwards. Okay, so the first method I'm going to show you, method 1. Now, if you think about it, the formula, okay, it could have some numbers, some n's, and some n squareds. So let's say the number is a, and the number of n's we've got is b, and the number of n squareds we've got is c. So the formula looks something like that. And let's work out, okay, this is our general formula. What would we get as our first few terms of this sequence? So obviously, if you put n equals 1 into this sequence, what do you get? Well, we're going to get a plus b plus 1 squared is 1 times c, so that's a plus b plus c. That's the first term. If we go back to the one we were doing, you can see, here's my formula. This is my a, this is my b, and this is my c. A plus b plus c, that's 6, isn't it? It's telling us the first term. So we're just kind of working out a general situation here. So let's put 2 in. And if you put 2 into this, what do we get? And obviously 2 squared is 4, so this will be 4c. And if we put 3 in, what do we get? Well, we get a plus 3b plus 9c. Yeah, 3 squared is 9, so 9c. And we'll do one more. (16c) at the end this time, yeah? Because 4 squared is 16. Okay, so let's now work out the differences between the numbers, or the letters. So in other words, what we normally do is if you want to work out the difference between the first and second, you do the second one minus the first one. So what happens if we do this minus this? Can we see that we're missing a B basically and a 3C? Yeah. If you do this plus this, it obviously has to give you this, the second term, so that works. Now what's the difference between the second and third terms? Well, you can see it's also a B, and then we need 5 C's. And then from the third to the fourth, we need an extra B, and we need 7 C's. Okay, so that's the first differences is here. Now, what about the second differences? And we already said that if it's a quadratic, the second differences should be the same. So are they? Well, can you see that this is 2C? And this is also 2C. So this is a general rule actually that we've got here, that the second differences is always 2 times C. So using that, it's going to be very easy to work out the C in the formula, because we're basically just half the number that we get for the second differences. If you go back to the one we did before, if you look, the second differences were 6. Yeah, so what we're saying is that 2C is 6, so that tells us that C is 3, which is right, isn't it? That's what we had in our formula. It's telling us the number of n squareds. Okay, so this is a very easy way of doing it, and both of these methods rely on this fact that you work out the second difference and half it. It will tell you the number in front of the n squared, the C's. Okay. Right, now, but how do we find the A and the B? Well, a good method to use, actually, well, there's 2 variations of this. One variation is just to use these numbers here. So this here, this kind of diagonal thing here, and compare it to the diagonal we get, let me just get rid of those bits, the diagonal we get here. Okay, because what we've shown is that, okay, the bottom number is 2C, okay, so obviously from that it automatically tells us that C is 3, so we have one of the things we're trying to find. The first number in the first differences is B plus 3C, okay, so what it tells us is that this 11 here must be B plus 3C. Yeah? Now, if that's B plus 3C, and we know that C already worked out that C is 3, can we see that this is actually saying that B plus 9 is 11? So obviously that tells us that B must be equal to 2, mustn't it? Yeah, so this works. And of course, the first number, the very first number of the sequence is always A plus B plus C. So we know that A plus B plus C has to be equal to 6, but we already know that B is 2 and C is 3, so obviously A has to be 1. And now we have all of 3 numbers that we need to write down the formula. Okay, so this is one variation of that. Now, a slightly easier version is to draw a line down here like this and work out the numbers that came before. Okay, I'll show you why that helps in a minute. So always the second difference is always 2C, isn't it? Yeah. Now, obviously, you can see the pattern here of the first differences. And if we want to go back, we can just do B plus 3C, take away 2C. Can we see that this actually must be B plus C? You can see it's following this pattern, B plus C, B plus 3C, B plus 5C, and so on. So what it's telling us is that the difference between the first term and the one before the first is B plus C. So can we see that this one would have to be A, because A plus B plus C would give you A plus B plus C. Yeah? So this gives us a slightly easier way of doing it. If I go back to this one and get rid of all this messy stuff. So imagine I had drawn the line going down here, okay, and work out the differences going backwards in the pattern. Well, the bottom one will always be 6. Now this is 11, and these numbers are going up by 6. So 11 take away 6. This number here, before this one, following this same pattern, must have been a 5. Are we happy with that? It's carrying on the same pattern. Now, if that difference was 5, then this number would be 1, because this is showing the difference between these two numbers. So if that's 5, the difference is 5, this number would have to be 1. So the first, this is A, this is B plus C, and this is 2C. So this variation, we would do A is this one. Okay, so we now know that A is 1, so fine. This number is B plus C, and the last number is always 2C. So, well, we've solved A. We know that 2C is 6, so we now know that C is 3. And because we know that from here, B plus C has to be 5, and we now know that C is 3, B has to be 2. Yeah? So it gives us the numbers that we need for our formula. Okay, so this method kind of, I quite like this method actually, if you want just a quick way of working out the formula, but you do have to remember these red ones or these first 3 blue ones, or you have to generate this whole kind of table from the general formula when you do the question. But to be honest, I think it's easy to kind of remember A and B plus C and 2C and kind of do it like this. If you can remember it, it's a good method. So let's do some examples. So let's take this one. So let's go through it quickly. So this difference is 6, 8, 10, 12, and the second differences are 2s. Okay, so what we do is we draw our line going down and we go backwards. So obviously this number has to be 2. You can see the pattern here, 6, 8, 10, 12. So this one has to be 4. Just do 6 take away 2, 4. And now we know that this difference is 4, so this number must be 1. So using our rule, A, B plus C, 2C, we can easily work out the missing numbers. So we know A is 1, that's easy. C, well, C has to be 1, doesn't it? Because 2C equals 2. And once we know that C is 1, then obviously we know that B has to be 3. So our formula is, what is it? It's UN equals 1 plus 3n plus n squared. Yeah, that's our formula. And if we want to check it, it might be a good idea to check in an exam situation. So here's the first number, second number, third number, fourth number, fifth number. Let's just check if the fifth number comes out correctly. So let's work out the fifth number in our sequence. 1 plus 3 times 5 plus 5 squared. What's that? 1 plus 15 plus 25, and that is actually 41. So it's working, yeah? Okay, so that's the method basically. So can I suggest, or maybe I'll do one more then, and then you can finish off the other two. Or if you like, pause the video and try this one for yourself if you like as well. So let me do this one. So if here the difference is 4, 6, 8, 10. You can see the pattern here, 12. Okay, and then it's 2, 2, 2, 2. Draw my line. Go backwards. So this is 2. Now this one's interesting because this has to be what, 2 as well, actually, yeah. And if I go back 2 from -1, this number must have been -3. So then I do my thing. So can we see that, well, A is -3. C is obviously 1 again. And if C is 1, then B is going to have to be 1 as well. So my formula, 1n squared. So that's the formula. If you check it, it comes out to be correct. Okay, so hopefully you got that right. And can you pause the video and try these two examples using this method, and then unpause it, and I will show you the answers. Okay, so these are the results that you should have got. You might have got confused on this one here. When you got the 4 here. Now 4 take away 4, you got a difference of 0 here. Yeah, but it's correct. It's still following the same pattern. These are all going up by 4, so you go back 4 and you get 0. But that means that the difference between the one before the first and the first one is 0. So these two both have the same result of 4, but that's perfectly correct. That sometimes happens with a quadratic sequence, that you can get the kind of the same number twice in a row. Okay, so these are the answers that you should have got. Hopefully it's fine. Okay, so let me show you the other method, the second method. Right, it's actually going to be easier to show you on an example. In fact, I'm going to use the same examples so we can check our answers. So this method starts off exactly the same. So we find the differences. So 6, 8, 10, 12, 2, 2, 2. And it's exactly the same principle for C, the fact that we know that 2C is always the second difference number. So we now know that C is equal to 1, okay, because that's the easiest one to find. Now what we do now is we think about the equation. So we now know we have 1n squared, yeah, because the C, if I go back, where is it? This one. We now know that the C is 1. Okay, we don't know the A and the B, but we know the C is 1n squared. So now our sequence is 5, 11, 19, 29, 41. Now imagine we know the formula was n squared, has an n squared in it. So what we're going to do is we're going to work out, okay, the part of the formula with the n squareds, and then see what we've got missing that we still need to account for, that we still need to use in our formula. So n squared, so the first number, if the formula was n squared, the first number would be 1, second number would be 2 squared, 4, third number would be 9, fourth number would be 16, and the fifth number would be 25. Yeah. Now if we subtract these numbers from our sequence, we will work out kind of what's missing that we still need to find a formula for. So 5 take away 1, 4, 11 take away 7, 11 take away 4, sorry, 7, 19 take away 9, 10, 13, and 16. Okay, now if we look at this sequence that we're left with, we can see that it's a linear sequence, and it will always be a linear sequence. Okay, and you can see it's going up by 3 each time. So what we do is we find the formula for these numbers. Okay, now what's the formula? We did it last lesson. Well, it's going up by 3, so the formula must have 3n in it, and the term before the first would be 1, so it's 3n plus 1. So can you see that actually our sequence was this top number? We knew it was n squared in the formula, so we put the numbers for n squared, but we were also missing these numbers. So kind of if you add these numbers together, you will get the numbers at the top. So we can just add together the two parts of the equation. So in the first question, our formula will be, well, we can write it in any order, but I'll put the number first like we've been doing. Then 1 plus 3n plus n squared. Yeah? Or you can write n squared plus 3n plus 1 if you want. Kind of, maybe that's more natural, I don't know, in this situation. Yeah? So this is quite a good method actually as well, because it's quite easy to do. So let's do another one. So again, we need to work out the differences. So quite similar to before. So this time again it's 2. So we know that the formula must have n squared in it somewhere. So let's write out our sequence. The advantage of this method is you don't have to remember the a, b plus c and 2c, but you still have to remember about the 2c. So we know the formula has n squared in it, so we do the numbers. And then we just subtract to see what's missing. So be careful here. We've got minus 2, minus 1, 0, 1, 2, 3. So the question is, what is the formula of this sequence? Can we see it's going up by 1 each time? So the formula must have an n in it. And the term before the first one is minus 3, so it's n minus 3, and you can check that and you can see it works. So all we do is add these two parts of the formula together and it tells us the equation. So in this case it's going to be un equals, I'll put the squared first, n squared plus n minus 3. Okay, and you can see that hopefully that was the same as what we had before. Yeah, minus, yeah, just in a different order, n squared plus n minus 3. Okay, n squared plus n minus 3. Okay, so pause the video and try to use this method on these two remaining sequences and then we'll check the answers. Okay, so in this question you should have found c equals 2 like we did before. So write out the sequence, and this time we need to use 2n squared. Okay, so instead of n squared, so here was the n squared numbers, 1, 4, 9, 16, 25, so you just need to basically double those. Yeah, so remember you do the n squared first and then you times by 2. So we have these numbers, and when you subtract them you get this. Now be careful here because this sequence is going down by 2 each time. So it means that it must be minus 2n, and the number before the first one would have been 4, wouldn't it, following on this pattern. So our final answer is basically that the formula is 2n squared minus 2n plus 4. That would be our formula for that one. Okay, I've put the next one on the next page to save some space. So you like we did before, you should have found that c equals 4 when you do the second differences and half it, you get c is 4. So the formula must have 4n squared in it, and then we subtract. Yeah, so you work out 4n squared, which is these numbers, and subtract, and we end up with this, and then we just need to work out the formula for these, which the difference is 3, so 3n, and it's going to be 3n plus 2, isn't it? Because the one before the first would be 2. So our formula for the last question is 4n squared plus 3n plus 2.